Welcome to Study Loop.
If I is the maximum current in the circuit, then we know that a half Li squared is equal to Q squared over 2C. That is, the energy stored in the inductor is equal to the energy stored in the capacitor by the conservation of energy. So if we rearrange this equation, we can find Q, the maximum charge stored in the capacitor. And this is equal to I times the square root of L times C. And we know these values. So this is 0.75 amperes multiplied by the square root, and the inductance is given to be 0.08 henries multiplied by the capacitance, which is 1.25 times 10 to the minus 9 farads. Hence we get the charge stored in the capacitor to be 7.5 times 10 to the minus 6 coulombs. Next, the frequency at which the circuit oscillates, omega, the angular frequency, is equal to 1 over the square root of L times C. And again, we can calculate this value. So that's 1 over the square root, and the inductance is 0.08 Henry times the capacitance of 1.25 times 10 to the minus 9 farads. Hence we get an angular frequency of oscillation to be 1.00 times 10 to the 5 radians per second. And from here, the frequency is simply omega over 2 pi. So this is the angular frequency divided by 2 pi, and that gives us 1.59 times 10 to the 4, and this is hertz. So finally, the maximum charge on the capacitor at t is equal to 0 means that the phase phi is equal to 0, and the current I is therefore expressed as minus omega times the maximum charge Q times sine of omega times t, since phi is 0. And hence we can calculate this current I. So therefore, I is equal to minus, and we calculated omega to be 1 times 10 to the power 3 to the power 5 radians per second times the maximum charge we calculated to be 7.5 times 10 to the minus 6 coulombs multiplied by the sine of omega times t, which is 1 times 10 to the 5, and time is 2.5 times 10 to the minus 3 seconds. And hence we get the current, the peak current, to be 0.7279. So this is the current after time t, 0.7279 amperes. And hence, since we have the current, we can calculate the energy across the inductor. The energy stored by an inductor, UL, is equal to a half L times I squared. So at this point, the inductor holds energy of half times 0.08 henries for the inductance, and the current 0.7279 amperes squared. And since energy is 0.0212 joules.